Okay, so this is sections 2.3.4 and 2.3.5, where we're looking at this idea of stability in there using fixed points, the terminology fixed points, but equilibriums, either one. So we can use those. Now, the reason I'm putting these together is I really probably should have put the last section with this as well, 2.33, 2.34, 2.35, because I pretty much did these in that video. So again, what we're looking at are autonomous differential equations. Let's try to get my N and my M in the right order there. Okay, autonomous, ODE. And so again, we're just looking at things like, U prime is equal to sine of U. That's quite the differential equation there, right? Because if I set this equal to 0 and look for those equilibriums, then I know that this is at 0, but then at also at pi over 2, or sorry, 2 pi, 3 pi, negative pi for that matter, and so forth and so on. So the way we would tend to write this is u equals k times pi. And now, if I look at this and think of the sine function, right? Well, what happens in between here? So, let's just kind of think of it along a number line this way, and then we can turn it vertically if we wish. But, here's 0, there's pi, 2 pi, 3 pi, minus pi, minus 2 pi, and so forth. So between 0 and pi, the sine function is what? Positive. Between pi and 2 pi, the sine function is negative. Positive, negative. And going the other direction, we've got negative, positive, and so forth. So if you look at this vertically, here's 0, pi, we'll just go up to 2 pi, down to minus 2 pi. Then as we look at the stability of these things, well, okay, between 0 and pi it was positive, so the arrow goes up. Between pi and 2 pi, the arrow goes down. Between 0 and minus pi, the arrow goes down. And the arrow goes up between minus pi and minus 2 pi. And so, as we look at these, we see this is stable. This is unstable. And we would see a pattern here, stable, that all the odd multiples of pi are stable equilibrium, or fixed points. Stable equilibrium, or unstable here, or stable. And, so we could see that pattern. And again, if we looked at this, from an initial point of view, if we had an initial value at say, time equals 0, but u, say, at pi over 2 or something like that, then we would see that this should head to pi over the long term. Alrighty, and I have no idea what the antiderivative of 1 over the sine is off the top of my head. Now it's not that hard because it's just 1 over the sine is the cosecant. So it's a logarithm thing, but I just don't remember what it is. And so that's the idea. Okay, that's all we're doing with looking at finding equilibrium and then or fixed point, and then determining whether they're stable or unstable. That's it. All right, we're done.